All right, most frequent digits. Here is the problem description of most frequent digits. I've taken the liberty of creating a test function or test method for it, which we call, and it includes this exact case. It creates that list, or I should say array, creates it dynamically, and then the result should be 540. Let's create a couple other test cases just for fun. For example, if you had an array that just was a 0, that should be 0. If it was just 1, that should naturally be 1. Let's do a few more cases. If it was -1, I presume that should also just be a 1. And that's probably enough cases for now. So these are kind of some edge cases. We should add some more, but I want to get into the game here, writing this thing. All right, let's write most frequent digits. So we're going to write this twice. First time we're going to write it, we're going to go through each digit and count its frequency. Count the number of times the digit occurs across all the numbers in the array A. Now, if we did this building up 0 up to 9, we'd be constructing our result in the wrong order. See, it'd be much easier if we constructed our results from largest to smallest, because if once we have a 5, if 4 also should be part of a result, we want to turn the 5 into 54, which is fine. Multiply the result by 10, add in the next digit. Easy peasy. So we need a helper method that's going to count the number of occurrences of a given digit across all the numbers in an array. So public static int digit count in array takes an array A and takes a digit, and result is 0 for each value in the array. You say result plus equals digit count of that digit in that number. Return the result. Now public static int digit count. It takes a number, it takes a digit, and it's the number of times that digit occurs in that number. So look what we did. We went through the whole array, and we're counting the number of times the digit occurs in each element of the array and adding those up. So then we have a helper method for a helper method. This one's just for a particular value within the array. Okay, so to begin with, n is math abs of n. Okay, import java util math. So now we have the absolute value, and usually when we do digit count, we have to treat 0 as a special case. So if n is 0, then what do? You say if the digit is 0, we'll go ahead and return 1, because otherwise return 0. So if n is 0, we have 1 0 if we're looking for zeros. Otherwise, we don't. Fine. So now our result is 0. While n is positive, what do? You grab off the ones digit. We've seen this so many times. N mod 10, and divide equals 10. And if the ones digit is in fact the digit we're looking for, then result plus equals 1 means we found another one, return our result. This is pretty straightforward stuff here. So now, most frequent digits. Well, what are we going to do? We're going to say, to begin with, we're going to assume that the 9 is the most frequent. So we'll say that our result is 9, and our best count is the digit count in array in A of 9s. The number of 9s, which is probably 0 in many arrays. Now we'll just add on the rest of them. The other thing we could have done, by the way, is say our best count would be impossibly large. And as we start counting from 9, we would find our best count is 0. Tell you what, let's actually do it that way. Let's start with the best count of 0 and a result of -1. -1 we'll use to signify there was nothing in this array. No, there were no integers. This is actually a cleaner solution anyway. So for each integer, for each digit, I should say from 9 down to and including 0, so long as the digit is not negative, we decrease a digit. So this loop here is kind of a weird loop. It's different from what we normally do. We're counting down instead of up. Perfectly legitimate though. Make sure you understand how that worked. Now for each digit, the count is this thing. We get the number of times that digit occurs in that array. Okay? If our count is greater than our best count, let's do it in 2 cases. If that's true, we found a new best count, gotta remember it, and our result has to just be that digit. So because we found a digit that occurs more than any other we've seen so far, so that's just our result. Otherwise though, if the count is the same as the best count, in that case, like we've seen, our result say is 5, because the 5 is the most. And then when we see 4, it's just as many 4s as 5s. That means that we have to change our result to be 54. So our result has to equal 10 times the old result to make room for the new digit. You might want to discuss this line right here amongst yourselves. I'm sure you understand why that works. And there's no Java util math. And it worked on the first shot. That was pretty cool. Okay, so now now we did that and it worked. This helper method stays. This helper method stays. This is a pretty cool way to do this, but we're going to do it another way just to show how you can do it with a list of counts. It's going to look pretty similar to this one. Let's actually do this and this. And so now I want to do public static int most frequent digits, again, of int a. This time what we're going to do instead, though, is we're going to create a list of the digit counts, which is a new int of size 10. Cool. So this is going to be a list of all the counts of all the digits we have, okay? So now what we're going to do is in one shot, we're going to go for each value of a, and for each value of a, we're going to say the next value, we're going to take the ABS of it, okay? If n is 0, that's the next value is 0, then we'll just say we'll increase the counts of digit counts of 0. That's the number of times 0 occurred. Otherwise, n is greater than 0, so we're going to say while n is positive, we're going to count all the digits in n right here. So we're going to go here and say the ones digit is once again n mod 10, and divide equals 10. So we're plucking off all the ones digit of each value of n inside, which is the absolute value of each value in the array. And now what we're going to simply do is say the digit counts of that ones digit plus equals 1. So in other words, if n was, say, n was the number 45. So we'll go inside here and we'll get the ones digit, which is 5. And the digit counts of 5 will increase. Then we'll, of course, shift n over by 1. So now n is no longer 45, it's just 4. And then the digit counts of 4 will increase. So in this way, when we're done, let's go ahead and system out println counts plus arrays toString of my digit counts. And then we'll just return 42, which of course is not true. And now we'll go ahead and compile this. And we go ahead and run this. And let's look what our counts came out as. So 0, 1, 0, 0, 0. So that was when we called it with -1. So let's actually call it, let's do this one first. And compile and run. It'll still crash. But look, This says we got 2 1s. There's 1 1. There 2 zeros, I should say. There's a 0. There's a 0. 1 1, 1 2, 1 3. 2 4s and 2 5s. So these counts right here are indeed counting the number of times each digit from 0 up to 9 occurs in this call right here. So it sure looks like it's working nicely. Now this feels like all of this belongs in a helper method, and surely it does. So you'd say public static list of ints. Instead of calling it digit count in array, this time we'll call it digit counts in array. I'll take an array A. It'll actually do all of this stuff that goes here now. We don't actually print that out anymore. We simply return the digit counts. So now our digit counts are going to be from that helper method, digit counts in array of A. Now we have this list of digit counts. Cool. So now the rest is actually going to look pretty similar, to tell you the truth, to what our most frequent digits look like before anyhow. So I'll actually go ahead and copy this. So you start out with your best counted 0 results, but now instead of saying digit count in array as that helper method, we have the digit counts already stored in this list of digit counts. So otherwise the rest is actually identical. So go ahead and compile this, and it does not like variable digit. Oh, because like that, go ahead and compile that, and we go ahead and run this, and sure enough it passed. So we found 2 different ways to do this. In the first approach right here, in fact, let's not even comment this out. Let's leave it in, but let's call most frequent digits 1. Let's call most frequent digits just most frequent digits. I'll do most frequent digits 2. Fine. We'll go down to our test cases, and we'll copy and paste. We'll do 1, 1, 1, 1, 2, 2, 2, 2, and show that they both work, which they do. So in the first case, for most frequent digits of 1, we had a helper method which told us the number of times this digit occurred in this array. And we had to call that helper method over and over again for each digit. And in the second one, we did it slightly differently. We created an array to store all the counts, and that allowed us to go through all the values one time. And each time we hit a digit, we could store it in that array of digit counts. See, up here in this first approach, the difference is we had to go through the array over and over again. Once for zeros, once for ones, once for twos. In the second approach, we only had to go through the array once because we were storing all the different digit counts on that one pass. That's what this bought us. So this feels like actually a better way to do it. But to do it, we had to have these variably sized array of digit counts. After that, aside from how you computed the digit counts, the rest of the solution is essentially identical for either one. I'm going to post this code to Piazza. You might want to talk it over. This video might not have had every little bit of this explained perfectly, so some discussion in class is probably a good idea as well. Be sure you thoroughly understand both solutions presented here.